So as Brian mentioned, I work in the design and construction industry. I'm a green building and sustainability consultant with Recollective Consulting, a firm that myself and 3 others started in Vancouver 5 years ago. And we're very proud to have worked on the Okanagan College Center of Excellence. It is targeting both leadership in energy and environmental design, platinum certification, as well as the living building designation. So we're quite happy to have been part of that project and looking forward to the tours and talks later today. So my presentation was subtitled, How the Last 100 Years of Design and Construction Have Contributed to Environmental Degradation and What We Can Do About It. I am going to talk briefly about the history of design, the key points in the last century, and how some of those changes have impacted us negatively, ourselves and the environment. And then I'm going to talk about, if the slides work, I'm going to talk about some of the things that we can change in order to address that. So 2 inventions became mainstream in the 20th century that had a profound impact on our building form. The first of those was fluorescent lighting. So with fluorescent lighting, we were able to cheaply light our buildings. And along with air conditioning, the introduction of air conditioning, that meant that we were no longer dependent on windows for ventilation or for natural light. So that meant that we could make our buildings very deep and wide, and that a lot of the features that you previously saw in buildings in order to bring in that natural light and air disappeared. So atrium, courtyards, light wells, those basically disappeared from modern architecture. Then with the introduction of electric cabled elevators, those square, wide, deep buildings that we had became very tall. And this form of architecture spread throughout the world and was in fact known as the international style. And that's what you see there. So when you combine this ubiquitous form of architecture with the economies of scale of manufacture, what you began to see is the globalization of materials. So we began to see manufacturing concentrated in certain areas around the world. As an example, if you walk into any office building in Canada, chances are that the carpet that you're walking on came from Georgia. If you've been in a movie theater that was constructed in the last 20 years, the seating that you're sitting on was manufactured by one North American manufacturer. So we have started to source all of our materials from the same place, regardless of where we're located in the world. So as a result of that, we see these concentrations of manufacturing across North America. At the same time, we began to introduce chemicals into our materials that we were using. So asbestos being one of those. Chemicals that we knew were carcinogenic. So asbestos has been banned in Canada, but it is used in a lot of other places in the world. Asbestos being one of those examples, formaldehyde, commonly used in adhesives, another carcinogenic, PVC, a plastic that we use in building and finishes, another example. And there are a lot of other materials that we use that have carcinogens in them. So as a result of some of these phenomena, what we saw in buildings were buildings that didn't respond to their context or their environment. When we got the ability to artificially light, heat, and cool buildings, then it didn't matter where we were building, they all looked the same. So a building in the Okanagan, which is semi-arid and warm, well, extremes of heat and cold, looks the same as a building you might find in Vancouver, which of course is a rainforest, with over 1 meter of rainfall each year. And that shouldn't be the case. We saw people becoming disassociated with their environment. We expect it to be the same temperature in a building all throughout the year. and we expect to be able to wear t-shirts in winter. So we have this disassociation with the environment around us. And we also saw, thank you, we also saw the materials becoming ubiquitous, as I've mentioned. Some of the responses that we have seen to this, and that we should see to this, integrated design process. So the process in architecture has been fairly linear. An architect and an owner will get together, they will determine the form of the building as well as the program, and then that is handed off to the other consultants. So each of the consultants then adds their system to the building. So the solution to the issues that I mentioned, not necessarily technology-based. I don't think that there is any new technology that will solve our issues. Integrated design process, that end of linear and having all stakeholders involved in the design from the beginning. This includes building operators, occupants, and the community. And it's extremely important to involve these individuals in the design. As an example, Beddington Zero Energy Development, or BEDX in the UK, designed, as the name implies, to be a zero energy project. But what they found was that the same suite, identical suites, with the same number of occupants, would have up to 50% difference in the amount of energy that they used. So clearly the occupant has a lot to do with the energy use of a building and should be a stakeholder in the design process. Systems thinking and integrated design go hand in hand. The building and the site are one integrated system in the larger system of the community. We have to reverse looking at the building as a collection of separate systems, which is what happened when we started artificially lighting, heating, and cooling. Reversing the order, it is common practice to design and then source the materials for the design. We need to look at what is readily available and then design according to that material. And finally, and most importantly, optimism in design. We have to approach design with optimism. We have to be designing to optimize the entire system. And you hear a lot about compromise between cost, aesthetics, and the environment. If you intend to compromise, chances are that that's what you'll be left with, is a compromise. So we have to change that so that we're designing to optimize the entire system. And we will see a lot of examples today from Okanagan College. So I will use one from Mount Royal College in Calgary, Alberta. This is a classroom there, and I've pointed out with a little arrow on the left-hand side, a light shelf. And light shelves work by bouncing sunlight off of the upper surface further into the room. It hits the ceiling and bounces back again. So it brings daylight further into the space. And then if you're putting daylight sensors on those interior lighting, you can further reduce the amount of energy used. It's also common practice to put ceiling panels, radiant heating and cooling panels, along the perimeter in the ceiling. But if you use this technology with light shelves, what happens is you get the heating and cooling bouncing off those light shelves and back away from the people in the room. So what they did at Mount Royal was to make the radiant heating and cooling panels the light shelf itself. So they brought the mechanical system into the form of the building. This brought it closer to the objects in the room that it was intended to heat and cool. It eliminated the need for a separate architectural light shelf and also the cost of that, and the occupants were more comfortable. So on the materials side, I will use an example from the college. The pine beetle kill wood. The design team looked at that local resource and they designed a building around the products that were available from it. And that was one of the great successes of this building. But Robert will be talking more about that and others today, so I won't carry on about it. So as Brian mentioned, I had an epiphany in sustainability mid-career. I was working for Workers' Compensation Board, now WorkSafe BC, and I left there to join an architectural firm. And one of my first projects there was for a client who wanted their office to be a showcase of sustainable, non-toxic material. As I researched that, I became aware that there was a connection between the statistics that I had seen at the Workers' Compensation Board and my choices as a designer. Few people know this, but more construction workers die from workplace-related disease than from accidents. So that means that the toxins that they're exposed to on the worksite kill more people than falls, electrocutions, falling objects, all other accidents combined. So when I made that connection, I realized that there's a different path forward. And the call to action here is not to accept the status quo. In order to realize a sustainable future, if you recognize that something is wrong, you have to act to change it. We need to imagine a better future and move towards it. Thank you.